Hello, my lovely grade 9s. We're moving into chapter 12 now. This is the second chapter in electricity. Today we're going to cover some of the basics of what is current electricity and what are the basic parts and the functions of the different parts of the electric circuit. Here's your homework that's required to do. It's going to cover 2 sections that you can read in your textbook and answer the questions. This will just help to enhance the information even more. Now, we've been talking about static electricity for quite a period of time, which is electricity that just doesn't move. It stays in one location on an insulator and doesn't typically move. Now we're going to talk when those electrons start to move around. They start to move or flow, and they go from one place to another, usually in a circuit, of course. We need to have a conductor. We've talked about the differences between conductor and an insulator. Conductor allows electrons to move along a controlled path, and there has to be a time component. Usually with circuits, it can just keep going and going along this path until we do something to stop it. Here we have the electron moving along its path over a certain period of time. I think we do that just to give kind of a little bit of a visual on that. Now, here's one of the things that as we move from static electricity. Now, why is lightning or shocking somebody not a form of current electricity? Because the electrons are moving from one location to another, and it does take time for lightning to go, or else we wouldn't be able to see it within that. Well, here's the key difference within them. Lightning is completely random. When we actually make a circuit and we actually are controlling electricity along a certain path, we're controlling what the path is and where those electrons are flowing. Lightning can happen anywhere, anytime. If we could predict it, we could probably solve a good portion of our energy needs. And lightning only happens, it's here, then it's done, and then we move on. So our static electricity, the electrons they can jiggle and move kind of in their isolated location, like we show with the balloon, but they're not moving along controlled paths. It's very random motion and it's staying in one place. We talk about current electricity, all the electrons are going to go along the path like they do in this copper wire. Now, let's talk about the circuit here. The circuit is where we actually have a path, and the path has to have a start, has to have an end, and it has to always end up in the same place that it started. Here's our electron moving along the path. I'm going to do it a couple times through the loop. Excellent. There goes the electron going through our controlled path here within that. And do note that we have the thing that gives us the energy, the cell. That's an individual cell as opposed to a battery. And then it's getting used up. All the energy that's being taken on that electron is being used up by the load, or in this case, the light bulb. Now, they always have to start and end in the same place, or we don't have a circuit. We'll talk about some of the variations of this as we move along. Now, here's the parts that we need to have for every circuit we have to have. We have to have a power source, which is a source that provides energy to the circuits, something that the electrons are going to carry from the power source to the load. So, for example, we're showing the cell here. That's chemical energy being given. We have our wall outlets, which comes from hydroelectric plants and provides energy through the circuits in our home. We've got generators, which convert fuel into electricity, so we're able to power different items kind of portably. And then we've got harnessing the sun's energy, and the sun is that gives us the energy in our solar panels as well. Now, in circuits, we always need something that's going to use that use up that energy, and that is the electric load. So it's always going to take that electrical energy. Now it's going to convert it back into some other useful form of energy that we need. So what we got here is we're talking about something like a toaster. It converts electrical energy into heat energy so we can char our toast within that. Here we have an iPod, takes that energy in, converts it into sound energy so we're able to hear the music that we want to hear. But it's always that changing from one form of energy to another. Light bulb takes electrical energy and produces light energy. As a byproduct, we get heat. That's why no lights are ever perfectly efficient. We have computers, which are going to, again, they're backlit, so we're actually creating light from electricity so that we can see what we're doing on the computer. And of course, there's many other functions in the computer as well. And things like our iPod, much the same as the computer. Now, we've got our electric load, we've got our power source, but we need something that's going to connect those. So we need to have a connector or conducting wires. In this case, we're showing you the copper wires. Okay, they are a path that the electrons can flow to get from one place to another. And they just connect everything, all the different parts of the circuit. You usually have them covered by an insulator. This way, we control the direction the electrons are going. It's also safety, so we don't get electrocuted by some of those electrons flowing out of our wall outlets in our homes. And now we've even started going into using light to help us with circuits, just because of the speed aspect of things. Now, the last part of the circuit that we're going to talk about is the switch. This is our controller. This is our flight path controller. It's controlling those electrons. Either they're going to allow the electrons to flow or they're not. It's on or it's off. So they are just controlling whether or not those electrons are moving. But we can take this out of any circuit and the circuit will still work as long as we reconnect those wires. But what it helps us with is it saves us from wasting all of our energy and also gives us a way to kind of control what's going on in the circuit. Again, those are homework, and I hope you use this podcast well.